It gets
Yeah.
better.
All
Yeah.
right. Well, I'm going to monitor my email, but I did start the recording. And as always, you do have the power to unmute yourself. We just ask that you stay on mute unless it's a time where you are prompted to jump in. And anything in between can go in the chat. And I will monitor that. And that includes any technical issues that you run into. So with that, I will throw it to our facilitators.
Okay,
Judy,
we'll
I
go
believe,
slide
or,
one.
oh, it's Manley today, right?
Yeah, yeah.
Yeah.
We'll
So
start out with a
let
couple
me
slides,
see if
and
I
we're
can get
gonna
it going.
look at some photos.
Okay, you're gonna do the photos first, or we're gonna?
No, we're gonna start with slides, and at some point we'll jump. You're gonna tell them about the CEUs real quick, and then
Right,
we'll go.
right. So, okay, can everybody see it? The opening slide there. Okay, you should, hopefully by now you've got an email address.
Okay.
We wanted to remind you, I know that many of you are working really hard to build your towers and to write your research plans, but we also understand what life is like in the summertime with families. So we have said if you could get anything that you were missing to us by 8 o'clock Wednesday night, because I'm going to start working on things. I know that I can't get to it till at least 8 o'clock Wednesday night. So that's when I'm going to start working on and trying to pull together everything. And I will be trying to give you more feedback on the research plans, but I had grandchildren all weekend and today. So anyway, but we do want you to complete them if you want the full 1 CEU credit, because that's what gets you from 6 hours to 10 hours that we are able to legitimately give it to you. We'd also want you to complete that final evaluation that Teresa will be sending you. And once you do that, once you do the final evaluation and we've gotten your homework in, then she will be sending out the CEU certificates for you along the way. And if you, like I said, if you have extenuating circumstances, then you can let us know, and we can work with you on that, because we're not that bad.
In case some people aren't accustomed to doing this, now we don't give you the CEUs. We give you evidence that you can earn the CEU, and you turn that into your school district.
It's like a certificate, and then you give it to your school district, and then they see what it is. And you should have, and you've got the schedule of what was supposed to be, what we were going to teach you along the way. And you will have copies sent to you of all of the PowerPoints, or rather links to all of the PowerPoints. And I think Teresa was gonna give you a link to a folder that has a lot of documents that I gave her to share with you today. And we're gonna be talking about a lot of the things that are in that folder during the 2 sessions today. And Manley, I will stop screen sharing and let you take over. How's that?
Okay, let me see if I can get my photos up here. I got a lot of stuff up there. The class coming up right after this. I'll find it in a minute. There we go. This one right here. Well, you know, it's about the last one on the page. Okay, I'm going to go through these. I'll go down through these slowly, and I'll apologize if you don't see yours. It might be I got it late or not in time enough to get it in, or if it was a partial picture of a tower, just the top of it, it might not be in there. I try to get, we've got enough pictures to show you, and I try to get those that show the entire tower if I can. And so let's see what we got here. I'm going to ask real quick before I get going. Can you see that, Judy? That picture, okay? I'm going to move it a little bit.
Yes.
Can you see it?
I can, but I'm seeing mainly you.
Okay.
So I have a set
all
up.
right.
Sorry.
Yeah, you make your screen smaller, everybody, and you can see the picture easier. Now, this one looks like it. These are mostly elementary. I got some middle and high. You'll see them a little bit later. This one's trying to get the height. I don't know how high this one was. It looks like it's about maybe 2 straws high. You see that some straws are straight up, and then the others are angled. So it's about 2 straws high. This one, and this one it's got a good base on it. You know, it's got a base so the bottom can't go out, and you got some straws vertical. I'm puzzled on this one. There are no popsicle sticks. Maybe the person didn't have them or whatever. A mistake that the students make a lot of times is they'll make a bed of popsicle sticks you know, because they know they're heavy, and they'll make it like looks like almost like a raft on the bottom, a flat raft of popsicle sticks to hold everything up so they can stack, it makes straws go up high. The problem is the strongest thing you got would be the popsicle sticks. So they need to be vertical, not horizontal. Of course, this person probably did not have any. So I'll go to some others here quickly. I got a lot of pictures here, but this is one of the first photos I got. This one's very tall. And I think I got the measure. See if it's up there on the side somewhere. I thought I had it, but this one looks like it's about 5 feet tall. 5 feet, you can convert that to centimeters. It's pretty high. She's probably got 1.5 meters tape. And now one problem I have with this one, when I look at it, this right here at the bottom doesn't look like legal. It doesn't look like legal materials. I can see popsicle sticks, which are horizontal, they could be vertical, and the card, index card, and then you got straws sticking out. So I'm guessing this is very heavy, and that's helping hold the straws up. However, this one may not be legal because you were only to use the materials that you had. Those things you get out of the kitchen for weight, that was for middle and high school to put on top of their tower to see if it would support it. And so we would only measure the height of the tower. If those are from the kitchen, we'd only measure the height of the tower from the bottom to the index card. So that one's going to be less than 1 centimeter tall. You're going to lose all your height because of these materials here. Okay, so I'll keep going. Sorry about that. And this looks like it was more of a middle or a high school one. And I can't tell about the height looking at that one. It might, I don't think that one's 30 centimeters tall, and it had to be 30 centimeters tall to qualify. Looks like if I enlarge it, that's about 6, let me see, I can see 1, 2, 3, 4, 5, 6, 7 or 8 inches tall. And so it's not quite high enough. If it was a middle, it had to be 30, and high school had to be 40. And there are a lot of straws at the bottom of this one. And also they use tongue depressors, not popsicle sticks. And they're horizontal, they need to be vertical. But so this one could be a lot taller if those sticks were vertical. And it's loaded right. You got the cardboard on top, and then you put the masses on top of that to see how strong it is. This one's probably very strong, it's just not tall enough. This is an elementary one, and it goes on and on. It's pretty tall. 46 inches, which you can convert to centimeters. You just roll your tape over if you want to. Usually it's on the back side. 46 centimeters. They used, it looks like they might have used a piece of cardboard or something for the base, which is not legal. It's got to be freestanding, and if the cardboard's not there, then it's legal probably because those are just straws. But the cardboard is just to be on top if it's a middle or high school. And this one's got a piece of card. If that's an index card, you're okay. If it's cardboard, it's not a legal material. But you see the popsicle sticks are not vertical, they're horizontal. It'd be nice to have those vertical. And all this is a lot of weight here, and you can see it's already swaying a little bit. So as you analyze these, you'll know where they're going to break. That one's going to break in the middle or bend in the middle. This one has a lot of structure, and it looks like it's legal. And I don't think I had a height on this one. I usually put the height next to them if it was given. This one could be converted to a middle or high by putting the cardboard on top. And this person made, I think, a couple towers. This is just one of their towers. That cardboard's just sitting there. As long as it's not taped or attached to those popsicle sticks, you're okay. You can move it and just sit on the table freestanding. So that one probably is legal. All right, this is a good tall one here. But it looks like it's taped to the cardboard. Again, we got that cardboard. That pesky cardboard was only from middle and high, not elementary. So that would have to be taken off. Then you'd be okay. I think it would still support itself, and that's a pretty tall tower there. That's probably about 30 inches, maybe 36 to their total in a house at the light switch. So you're looking about 40 inches tall. They got a nice flag where you see the top of this one. Looks like it's pretty good as long as they didn't violate the tape. It looks like there might be cardboard. They'd have to remove that cardboard at the bottom. And they didn't use all their popsicle sticks. They could have had maybe I'll show you in a minute how to do that. 3 popsicle sticks vertical, and that whole tower could have been a lot taller by making those popsicle sticks vertical. And this one looks like it's just sitting on the floor, so it looks like it's legal. I don't know what that is, that yellow piece there. If that's maybe their tape is that color, I'm not sure. Looks like their tape is blue, and I'm not sure what that is. Maybe it's a straw of some sort, I don't know. But that one's a pretty tall one. And here's another one that's sitting on a table, and they use like a little skid here, and these are all, looks like popsicle sticks going across there, and maybe here's the straws. So this one had some height to it. It's a unique design. I hadn't seen one quite like this, and you can enlarge, we can send you these later, and you can enlarge it to see how tall that really is. Probably, let me see. All right, probably that's 1 foot, 2 feet, 1, 2, 3, 4, 5, 6, 2 feet 8 inches probably. Okay, here we got one. Looks like a middle school or high school, and it's got a lot of height, so you get a lot of points for that. Cardboard's on top. It's freestanding. Looks good. It's got cross braces, which if you did research, you see that cross braces are good. It would be really good to have another cross brace through here, going the opposite direction, and maybe another one across here, and then on the other side have cross braces. These cross braces form triangles with the structure and make it a lot stronger. You find that out doing the research. This was on the right's an elementary one, on the left's a middle school one, and I don't know how much this one held. I got some in a minute. You're going to see some things on top, which are pretty heavy. Got some that were pretty massive. Here's a nice tall one, elementary, and that can't use the cardboard, but it looks like it's okay. But there might be a piece of tape there to the cardboard, and that would not be legal. Okay, you can see they're getting ready to load. This is a middle school one. Good design. These could be straws instead of popsicle sticks. They could use the popsicle sticks for vertical. They look like dowel rods though, and instead of popsicle sticks. But you'd want popsicle sticks. I'm going quick. Good middle school one. Good one. Okay, and I think this one's made for middle school. A lot of straws, a lot of support there. And let's see, I think I got a picture of it. I don't know how tall it is. It looks like to me, it might be 30. It might be. It's got to be 30 from right here down to qualify. It's got to be 30. I'm going to go back up and let you see what it's holding. A whole can of Progresso soup and 3 cans of tuna. That's a lot of mass on that one. So we need to make sure it's at least 30, and that'd be a good one for middle school. Another middle school, and it doesn't have a load on it. And another one, middle school. You can see all the triangles in that one. And here's one you can see from the side. They didn't have popsicle sticks. They used tongue depressors. And really, it would be better to have the tongue depressors vertical and straws going across there, because you're losing the strength of the tongue depressors. 2 more models. You can see a lot of different models here. I'm go ahead quickly now, see if I can get to the end. I think there's 1 or 2 more. Now, on the left's the model they built, and on the right's the model with 2 cans of Progresso soup, and looks like 2 cans of pineapple. That one has a lot of mass on it. Again, I'd have to make sure it's at least 30. Looks pretty good. Here's some elementary teachers building one, not in this group, just from the summer when we were together. You see how they built it. They're only using straws. I don't even think they're using popsicle sticks yet. All right, Judy, I think I'm going to quit on that now and go to just me for a minute. I'm not going to quit sharing here.
Okay.
Okay. All right. And so I'm going to make mine. You see me okay, Judy?
Yep.
All right.
Okay.
Right here, I'm going to hold this up. I don't know what happened. We went to some slides all of a sudden.
Oh, never mind. There you go.
Okay. Well, I got some popsicle sticks here. Just a quick to show you something you could have done. This could be 1 strand of popsicle sticks. You can almost get the height just with these taped at almost, and they overlap a little bit. So that would be a good way to get some height with the materials you had. And this is very, very strong. You could put a lot on it, especially if you had 4 different ones of these. One thing you might not have noticed is I'm showing here how to combine a straw and a popsicle stick. I sliced the straw with a pair of scissors. I cut it and put a little piece of straw where it split is on each side of the popsicle stick, and it's taped. This is a very strong way to connect straws and your materials. If you look at real towers and bridges, they're connected this way. Another thing that, here's a lot of you did discover this. I connected this just the way I just showed you on both sides, but this is at an angle. And so if I had another one going the other angle, I can have some triangles in there, and this will be stronger. And it's got two different legs. You can see it at a distance. And this is very strong with minimal materials. And then everybody kept asking me, Judy, what the index card was for. I want to show you a close-up of that. Here I just have one straw and another straw, and they're bent and joined. And I want to make sure they don't come apart. And what I did is I cut the corner off my index card. And the corner of my index card is right here, taped in 2 places to the straws. And this is very strong because an index card, here's your index card, it's weak this way, but it's very strong if you try to pull it apart. And so these are called gussets. If you look at real bridges and towers, they're going to have little thin plates joining a horizontal and a vertical piece of the structure, and the thin plates are riveted on the 2 sides here, and that keeps the tower from swaying one way or the other. This is very way to make a tower very strong so it won't fall over. So this could have been used on both the all 3 elementary, middle, and high type structures to keep them from falling over. That's just a few things that you learn in looking at the research. And I think it's good to build things like this. I hope you enjoyed it a little bit. You learn a lot about building. If students are going to build, they need to do some building just to learn about the materials that they're dealing with, and they need to look at the real structures if they're going to make models and make the models accurate as they can. Of course, we didn't do an engineering problem here. All we did is just how to work with something that you're going to build and engineer. All right, Judy, we can go to the slides.
Okay. Yeah, because that's got more of what you were talking about.
Yeah. And the next one there. Yeah, that's what there are many types of engineering too. We were just doing civil engineering. We can go to the next one. Now, if you're doing an engineering project, this is going to be the point. They're going to make something that new, original, or they're going to solve a problem. Or they might propose that you use different materials or different design to build an existing type structure. If they're going to do that, then they need to make sure those materials can be purchased more cheaply, or they're easier to obtain, or they're stronger. And so they're building a tower that's, or whatever they're building is just as good as what exists out there, but they've improved on it by making it cheaper or stronger, or maybe to withstand conditions better. And they're going to compare it to what's already been done, so they need to do their research. And then they have to test it. They're going to have to test it to failure in case like this, and they measure their results. They've got to have a way to measure the results under different conditions. Like an earthquake-proof house, they're going to have to simulate an earthquake. And they're going to test it to failure. They're going to revise their model and retest. And they're going to have to explain and make a case why their way is better. Okay? And go to the next one. I think these are just some examples, quick examples. We saw this last time, just to give students some ideas. They might want to pursue some of these. Like that next to last, improve the health of a local stream. You know, they might want to come up with some way to do something, make some kind of filter for the water, or do something so they can take harmful things out of the water. So that could be engineering, but not the same kind of engineering we've been doing here. Okay, other example problems, like that first one, and you saw this last week. If you're doing lockers, they're going to have to look at existing lockers and find out what they're all about and whatever, and find out the ins and outs about lockers. If they're going to make a better locker, it's got to be better for some reason. It might be that it's easier to get into. Maybe it's more secure than others as far as being able to figure out the combination or whatever. But they got to have a good reason for why they're building it, and then they got to have some models and show how they work, and so on. I'm not going to go through all these, but the whole idea of the engineering project is to do something to solve a problem that exists, maybe that hasn't been solved before, or to take something that's already out there and make it better. Okay. All right. Before we go into that, I want to know if they have any questions, Judy, or if
Yeah,
people on the chat, just for a minute on the chat, if you have questions you want to ask, we can answer quickly, and then we'll go on to the research plan. "19 minutes, Judy." That was 19 minutes.
So,
Okay, no
yes,
questions. I don't
Yeah.
see any questions. We've got 35 people.
Okay. All
I
right.
tried to answer questions as they asked them. People did ask a lot of questions while they were building and whatever. I tried to answer those, but the students like building. And, there are lots of things to build. They can build cars and airplanes and buildings and things that can build things to do things. Like I mentioned, a filter. Students, I saw some students last year that were building a way to keep trash and pollutants from going downstream on a stream. A way to let the fishing things through, but they were trying to figure out a way to keep things that wash off the land from going down the stream and going downstream into the river and whatever. Just an example. And that was an engineering project. Lots of engineering projects. I know some students that were working on a way to get food and medicine and clothes into Puerto Rico, how they could do drop things from airplanes so that it wouldn't damage what was in there, but could be done more cheaply than in the past. And they could reuse the containers. Just all kinds of ideas. All right, Judy, no chats. Well, 2.
Oh, there's a couple now. Yeah. Star is asking, do you know of a resource that has engineering project ideas that correlate to the state standards?
Oh, well, you're going to find, if you just look for engineering projects, it's going to be unlimited. I mean, there are going to be sources everywhere. The hard part, though, is to get your students to do one that hasn't already been done. There's a real tendency among the students to see a great idea and want to copy that idea. And that's what they should not do. So sometimes I don't show them a lot of projects to start with just because of that. But they've got to come up with a good idea that hasn't been done. And it's endless out there what they can find. I don't know of any one particular source. I know I work with Science Olympiad, and we build 7 different things there. And so Science Olympiad has 7 different things that they build. And you can look at the winners from each year. They put them on the web. You can look up past years. Okay, related to COVID-19 and ways to improve safety. Now, Judy will probably get into this with the plans in a few minutes, and so I don't want to steal thunder there, but when you start talking about something like COVID-19, they're going to have to find a way, whatever they build, they're going to have to find a way to measure its effectiveness. And I'm sure, let's come back to that question later, Judy. How would you might measure the effectiveness? You might not want to do it with a real virus, because you wouldn't be allowed to. That'd be very dangerous.
Yeah, they can't.
They're very careful at the CDC doing things with dangerous viruses. So you wouldn't want to do that, but you have to figure out some other way to check the effectiveness of different materials. Okay. And you don't want to use them on humans unless you have to, because then it gets even more complicated. So we'll come back to that later.
But there are some things that we can be looking at. Yeah, I see the air
Yeah.
liquid particles going through materials. Yeah, it's a good one. So these are 2 slides. I'm bringing them back up again about the research plans. And I spent since most of the research plans came in yesterday afternoon, right at noon, early morning. I didn't get through all of them, but it looks like most of you got the general idea. I did get some questions, and I will be going through them and try to give you some feedback on them, because I think that's important for you if you're going to be working with your students. If you don't get feedback from me, it's kind of hard for you to get feedback back to your students about what's going on. Do want to point out that it is easier. I had a couple of questions from people. Should you write it in a list, or should you write it as a paragraph? And it really is much better to write it as not in a paragraph, but in a sequential manner. As to, I'm doing this, and then I'll do this, and then I'll do this. So it's more of an outline, or it's a stepwise 1, 2, 3, 4 process along the way. Now you can have it divided up into sections as to what is my hypothesis, my problem, my need, or my goal that I'm working on. This is my timeline. Then you've got another section about my materials that I'm going to be needing. Then a section on your methods that you're going to be working on. A section then on your testing, the type of data you're going to collect and how you're going to be testing it. and how you're going to analyze it, and then a section on any safety issues that you have. So if you do it that way, it is more of an outline with steps in between. One of the things that I will reiterate again is these research plans need to be approved by whoever is supervising the student before they begin that process of doing the experiment. And so this is a slide about the data that they're going to be collecting. They need to make sure that they've got those controls in place, that they're only manipulating one variable instead of multiple variables. And it's real easy in a lot of experiments that I saw that there could be a lot of variables that had an effect on your data. And so you have to figure out a way to limit those variables, and they have to be large enough numbers to be able to know if it's something that's actually happening or whether it's just, it happened this once, but you may never be able to repeat it again. So in the bibliography, I think most of you gave me, all of you gave me a bibliography. And then, so I want to get some of your comments back on what you thought about these research plans. And I want you to think about what you did. And was it easy or was it difficult for you to come up and limit your variables along the way? And do you think this is an issue your students will be having? They're setting up a project.
And Judy, do you want folks to answer in the chat?
I would love for you to answer in the chat. So I guess if you could tell me as well in the chat, first of all, was your project a scientific or an engineering? I just kind of like to get a poll for everybody to see. Just say scientific or engineering in the chat. Okay. All right. So I'm seeing that looks like most of you are doing scientific project. I thought it was interesting. Kriya said that there are too many variables, so she chose to start with the easiest one, scientific. Most of your students will think that the engineering model is easiest because they're starting with something from scratch, and they're testing it, see if it does one thing or not. So it's a little bit different when you're talking about variables, when you're talking about scientific versus engineering along the way. I do think also that most of our training, unless you have had an engineering course, has been in doing scientific modeling with our students and having scientific projects with them. But I think usually your students seem to think, from my experience, is they really enjoy the engineering one where they're solving a problem instead. And so
Judy Starr also noted that she, like as she did her research, she ended up having more questions and thinking about her project differently.
And that's perfect. That's really what you want everybody to do, is that the more you work on it, the more you realize that there are other questions that can be asked. But you have to finish with testing the one thing you're testing before you start doing something else. So any good question leads to more questions. So that was great. I'm glad that happened. What did you think of the rules wizard? Answer in the chat, please. Comments about that. Oh, it's great to find out that you, some of you are already using it. Okay. All right. So with the rules wizard, sometimes depending upon your class, it may be something that if they have the technology available in a group setting, you can go over it with them as they're doing it and being able to help them if they have any questions about what how to respond. And again, if the students don't answer the questions correctly, then you're going to get some weird results for the forms that you need to have. Okay. All right. Next question for the chat. How many of you had any special circumstances that the rules wizard told you that you needed something besides Form 1, 1A, 1B, and the abstract? That would mean you're probably doing a project with humans, animals, vertebrate animals, biological agents, or potentially hazardous materials. And Form 3 is the risk assessment form. And we do have some regional fairs in North Carolina that require every project to complete a Form 3, which is that risk assessment, because it makes you look at exactly what the students are doing and to find out anything that they're doing that might possibly cause any, be a safety risk for them, and how they would be handling that and dealing with it. And they just feel like that it is safer to have the students and parents and teachers work through that to look at each project for potential risk. We've got someone who did a human consent form, and we're going to talk about that form a little bit more, but that's because that's something that's really important. Someone else said that they had to have a form for working at an institution. I'll talk about that a little bit more. And that's a really important form. That is one of the ones that is displayed at the project at a competition. And it is now 2 pages, and it goes over what exactly the student did and what was done by individuals at the institution or at a corporation or somewhere that they may be working outside of the home or school. So when the judges are going through, they can easily tell, how much of it was student driven, how much was driven by wherever they were working and at the institution. So that's a good one to go over with. Looking at, we talk a lot about the rules and regulations at ISEF. I will go back that I encourage you, even if you're going to just be doing projects in your classroom, if the students have the ability to choose what they want to do and there aren't constraints of what they are choosing from, it is still an excellent idea for you to have them look at the rules and regulations on doing research on a particular topic. The International Science and Engineering Fair is the largest international student competition in the world. They have worked very hard, and they continue to edit the rules and regulations to try to make them clearer and to protect students and the people that are working with the students. It is also for your safety and for your liability issues that you have them do this, that you know that they're doing it safely. So looking at a little bit, again, while we do this, especially if it goes outside of your classroom, or if the students have ability to choose what they want, it puts more pressure on you to really guide them. It does protect you, it protects the school. As students are reading through the rules and regulations, it kind of raises their expectations for the work that they're going to be doing, because they know they can't always take the easy way out. They're going to have justifications. They're going to have background information about what they're doing. If you have students that want to go to a higher level competition, it may be required that this be done before they actually start their research, or else they wouldn't be able to qualify. And the reality is, the scientists and engineers have to have things reproved all the time. So if you're working with humans, I was at NC State for 26 years, I guess, and they definitely have what they call an IRB, or Institutional Review Board. Anything you do with humans, even a simple survey, has to be approved by the IRB committee at the university for you to be able to send it out. And it's the same way if you're doing research in a corporation. If you have humans, somebody has to approve it. And anywhere you go, those are the rules and regulations. And so we're really teaching students, this is the way science and engineering is done, by making them understand that you can't just do whatever you want to, that somebody has to say, this will not harm somebody else and it will not harm you along the way. A lot of these forms must be reviewed before you experiment. So I've given you on the PowerPoint, and you're going to get this, so don't worry about writing down the long links. But these are links to the international rules. And I think also that Teresa gave you the link at the beginning of this session that will take you to the folder in the Google Drive that has all of these already in place. But you can also get them by going on. In fact, let me stop sharing for a second. Let me go to, I've got them ready to pull up. If you go to ISEF, this is societyforscience.org/ISEF/international-rules. For student supporters, now I know that if you work with elementary students, that a lot of this may be over their heads, but you need to be aware of what the rules and regulations are to make sure they aren't doing something that these rules and regulations say this isn't safe. Because if it's not safe for a high school student, it's definitely not going to be safe for an elementary school student. This has a link on it for the Rules Wizard. And I think I forgot to share this page. So let me go back. I was talking about the web page, and let me share it with you. There we go. All right. So this is what I was talking about. You have to call me out. But this is a link. They've completely redone the ISEF web pages, so I had to go back and find everything again this year. This is a great page because it gives you information. The Rules Wizard, if they're going, we only have 7 categories in North Carolina because we don't have enough space, enough judges to have 21 categories. We'll talk about display and safety rules a little bit. They're common questions that people have about the ISEF rules. And then this is the overview of all the different forms, talks about when to use it. So that's good information. This is the link. They do have the rules and the guidelines in Spanish. And I know many of you have students that are Hispanic and parents may speak limited English. So this is a great link for you to give so that they can read those rules and regulations in Spanish, because one of the things that these parents have to sign off on is they've read the rules about the research that the student's going to be doing. So there is a link to having them in Spanish for you to be able to use. Again, as ISEF says, the purpose is to protect the rights and welfare. And you need to look at, this is something we need to consider with our students. Okay, so I'm going to stop sharing.
There's a question. Are students allowed to present their projects in Spanish?
That gets into the point of having someone who can interpret for them. So at ISEF, they have interpreters, and the students can present in their native language because they come from 70 different countries, but they have interpreters there. We don't have interpreters at our regional fairs and at our state fair. So unless there is some way for you to have an interpreter in place who is not a family member, who would be a little prejudiced, but have someone, you may have that option, and that would maybe give a student that may have felt like that they were not really participating, make them a part of things. If that's something that you can do in your class. Usually we have them do the presentation in English and the board in English. But again, even if the board is in English, if they want to talk about the board, because about a quarter of the points that they get in judging comes from that interview process. And so if they were more comfortable answering questions in Spanish, if you can get a Spanish interpreter, that would be fine with us. It's just we can't furnish one for you along the way. So let me go back and see if I can get in here. All right. Okay, so as you all found out when you went to the Rules Wizard, every single project has to have forms 1, 1A, and 1B. They have to have a research plan, and they have to have the abstract. And if when I was in the classroom, I had a paper allotment, I could only use so much paper before I was told, I'm sorry, that's it. So we have tried to help you along with that. And by creating, and I just went back and revised it all. And this, and the next slide, I believe. This is the Rules Wizard, we talked about that. So I'll tell you the links. I've created a sample Google form that we'll look at for you to use with parents and students and for the supervising teacher to look at. So these are the forms themselves. Form 1 is basically a checklist for whoever the sponsor is or the teacher who's overseeing the project, or if they're working at a university and they're working independently, they may not be working with their school. Whoever is supervising and monitoring that student needs to complete this checklist. And really the top portion of it is all that is filled out, unless you have special circumstances. And it's pretty easy. You have to know the student's name, have to know the project title. You have to say, I've read the rules and regulations. Then you have to say you have received the checklist that the student has to do, and that you've discussed with the student any rules and regulations that pertain to the project, and any possible risk, what the safety issues are. And then it asks if the project has to do with any of the things that require prior approval. And and that's in question 4. So if any of those are checked, then question 5 is just said, these are the forms I'm turning in, which are the 1, 1A, 1B. But then below that, it has, if you're working with humans, you need to check that, and then you say what you are turning in with it, or if you're doing vertebrate animals or potentially hazardous biological agents or hazardous chemicals, activities, and devices. Those don't necessarily have to have SRC approval, the others do. Or if you have to need a risk assessment form, and then the adult sponsor signs it and dates it and gives their email and their phone number. So that's really all that's not much to check on that, but it does say that they've looked over everything. The student checklist.
Oops, sorry, Judy. I just wanted to give you the 5-minute heads up before break.
Oh, okay. Oh, great. Okay, so anyway, y'all can look at the forms and read them. I will move quickly. So, but these really, it's not as difficult. There's not that much on there, as you'll see when I show you these. I am going to bring this up, and I think I've already, let me stop sharing that and then share my Google Drive. All right, let me see if when I move, you get this. Okay, this is a sample that I created for the parents and teachers. It is a Google form that you can take this and build off of it and make it to your own. I've got the student's name, the working title. Basically, I went to forms 1, 1A, and 1B and pulled what is needed. So going back to your paper allotment, you want to be able to cover things, but you don't want to send home 5 sheets of paper or 3 sheets of paper, or you can't even print out all the paper for your students. So you can do this by having them complete this online form, and it has on it a date. So this would need to be done prior to their starting the experimentation. I did one that covers form 1, which is the checklist for the sponsor, a student names, and if it's a team, it would have all names on it, the working title, what the sponsor's the first name, last name, the email, and I forgot to put phone number in there. Then it asks if you've reviewed the rules, because that's one of the questions. If you've read the research plan and the risk. And then it asks about if it's human subjects, if they've completed form 4, and yes, no. Yes, they have them, but we haven't finished form yet. So I gave you that option on all of these things that have extra approvals that are needed. So when a student completes this, or parent signs off on it and they check it and send it in, and this can be done on a telephone, if need be, or anything that a tablet or Chromebook or whatever, besides a computer, to get this approval. When you get that date down at the bottom, this is the date that can be used when later, if the student progresses to a regional fair, they can take the data that went into the responses or an Excel file and then fill in the paper forms or online forms. You can actually fill them in online with the data that was collected by these Google Forms. The one thing I will also say, teachers, as you collect the data, and I haven't filled out any of these yet, when you get the responses back, if you see any projects that say they're using animals, humans, or microorganisms, or potentially hazardous biological agents, you know you're going to have to go to those students and they're going to have special permissions before, and maybe a supervisor that knows an expert in that field to okay it and fill out forms before they can actually start on their project. If all of those say no, and you've read the research plan and everything looks safe, then you can get them started and let them go to town. But if you've got a yes on any of those, then you know that you need to look a little further and they need to get special permissions before they move forward. So let me go back, stop sharing that. I wanted you to be able to see that. Nope. All right, so you have those links that you'll be getting. That risk assessment form 3 we talked about. I know Region 6 requires this by every project that comes to Region 6. And some of the others now are requiring it as well. It just goes over any risk and talks about it. And then whoever is supervising it has to sign at the bottom. If you don't know whether or not you should do it, fill it out. This is the human participation form. We get so many, and I was regional director for Region 5 last year. I got so many projects that had student subjects in them, and they had never heard of this form. So we're trying to get the message out. The student fills out the very top portion of it. The IRB committee fills out the middle portion and then signs it. If the IRB people don't check the middle portion, even if they've signed it, I have to send it back to them. Your IRB committee can be people that are on that scientific review committee that looks over these hazardous projects. But the IRB, or Institutional Review Board, has to have a teacher. You cannot review your own student's project because that's considered a conflict of interest. It must have a school administrator on it, so you can get your principal or assistant principals to look over that. And it needs to have a qualified health or medical professional, and that can be a number of different people. And I think I may have that in mind. Yeah. And that next slide here, the health and medical professional can be a psychologist, a medical doctor, a licensed social worker, licensed clinical professional counselor, physician's assistant, doctor of pharmacy, registered nurse, and it also could be a nurse practitioner. That wasn't listed, but that would be fine because they're more than a registered nurse. So
Judy, yeah, I think if we can save SRC for the opening of the next session so that folks get a break. Right. There is, before we break, would you quickly answer, there was a question, are electronic signatures accepted?
Yes, electronic signatures are accepted. And if they go to the links at the state site, and if they go to the links at ISEF or if you use the forms that are in the link that you got to our Google Drive, if you download those, all of those forms can be filled out as PDFs and saved, and an electronic signature is accepted because that is dated.
And then do school nurses count?
School nurses most definitely count.
All
All right,
right.
Judy, let's go to the next session, and then they can ask questions as they come on. if they
Yes.
have
Okay.
questions.
So
Right.
we will stop recording here, and we will give you all that break until 4 o'clock.